Okay, so now what we want to do is just talk a little bit about angular contact bearings. Now, all the principles are the same. You have the outer race, inner race. You have a collection of a medium in here, which those things to ride on. So again, it's essentially very much the same as what we've already been doing. So if you have to put this bearing on, you're going to use a mandrel, you're going to use heat, you're going to use whatever is appropriate to install that. And the same thing is when we looked at putting bearings into the housing, we've already done that, right? With the plain bearings, we're able to press them into the housing. So again, depending on what you need to get set up is what you're going to do. Now, why do I want to call out angular bearings? Now, and what is an angular bearing? Well, essentially what an angular bearing is it is a bearing that is set up with a contact between the race and the balls or rollers in this sense, to where they take a much higher axial load in one direction. Okay, so in other words, the way this is set up is that there is much more material on this side of the roller balls in there. So if I were to force on the race this way, I'm going to get a lot more protection. I'm going to get a lot more strength in this one particular orientation. Okay, whereas a ball bearing, you're going to get the same either way, but you're not going to get nearly as much as if you were going in one direction, the appropriate direction on an angular contact bearing. Now, oftentimes these angular contact bearings are set up in a series of two or more, and they are placed on an axle or in a housing to where you get different scenarios, if you would. So in essence, if we're worried about this particular shaft here, okay, and we have a lot of force on this shaft in this direction, so we have a lot of axial load in this direction, then I'm going to orient the bearing to where I can see the race over here. So that means I have more material. So this bearing has the most strength with the load on the inner race going in this direction. So I'm going to stack this bearing and this bearing. So I'm going to get a lot, okay, of axial load protection, if you would, in this orientation here. Now, I get a little bit this way, but it's not nearly as much as what I do in the other direction. So what also could happen is if I need the load in the other direction, I can just flip both bearings the same way, put them back on the shaft here, and now I have all my axial load capabilities in this direction. But what if I were to need axial load protection in both directions? Very simple. What I could do is I could actually reorient this particular bearing to where I have load protection with the shaft pushing here, and then orient this bearing with the load protection where the load goes here. And so by doing that, what it allows me to do is have a very high axial load rating in this direction and this direction for this type of bearing here. Again, it's not one for one. These deep groove roller bearings here, or not roller bearings, but ball bearing here and this ball bearing here, this is going to have a particular axial load in both directions, and it's going to be equal. This one here is going to be unequal. It's going to have a much higher rating in this direction than it is in this direction right here. So depending on what you need for your design, your mechanism, these bearings should be used and aligned appropriately for whatever you're trying to get.